When we think of islands, we often think of maybe beaches, pristine views, waves crashing against the shore, or that perfect sun-kissed tan that you would just love to cultivate. But in many ways, islands aren't interesting because of beaches. They're interesting because they're cut off. And when you cut life off from everything else, it starts to change. Studying these changes and how life adapts to these island conditions is called island biogeography. Now, island biogeography encompasses a lot of things, but it essentially washes down to about three main driving factors: distance, size, and time. Start with distance. If an island is too close to the mainland, stuff is constantly arriving. Usually things like seeds, birds, insects. There's a steady flow back and forth. But push that island further out, and that flow almost stops. Now only a few species make it. And the ones that do, they're stuck. In most cases, the journey back is not even worth the effort to attempt. And essentially nothing new is coming to mix things up. So evolution starts working with whatever made it there first. This drives endemism, which is higher amongst islands than anywhere else. Endemism is the term that refers to an animal or organism that's only found in one region of the world and nowhere else. Another main factor is size. Big islands are stable, more diverse. Consider Isabella Island for an example. It has more space, more habitats, and populations don't crash as easily. Smaller islands, like San Cristobal, are the opposite. Everything is fragile. There's one bad season, an entire species could be gone. So even if something arrives, there's a good chance it doesn't last. That is, unless we brought it over and it destroys everything living there. Finally, we consider the effect of time. This is where things actually get interesting. Leave a population isolated long enough and it stops being what it was. Not immediately, but slowly, generation by generation. Whatever arrives starts to radiate or adapt to their location. And in many cases, organisms have to make an important trade. Is it better to disperse across a wide range of islands and risk being able to find a mate? Or is it better to specialize in one specific niche or microhabitat on the island? On islands, many species, even generalists, are specialized to a specific habitat or plant type. Specialists very often have a practical advantage over generalist species on the islands. After enough radiation and specialization, what's on the island usually looks nothing like anything on the mainland. That's how you end up with things like flightless birds, giant prickly pear trees, marine iguanas, daisy trees, giant tortoises, or insects that exist only on a single island. I wanted to quickly explain another topic that falls under the umbrella of island biogeography. This one particularly relates to ants and other insects. We mentioned earlier how there's an important trade-off between specialization and generalization. There's another one that relates to some of the topics that we've discussed on this channel before, namely ergatoidy and wingless conditions. Oftentimes, ants on an island will decide that instead of dispersing via flying around, they will become wingless and disperse mainly on the ground. Very often, they will make a trade-off between spreading as far as they can via nuptial flights or specializing and restricting themselves to that specific island. Many of the island's native species, in terms of insects, are limited in that way. Many become wingless or specialize to only exist on a specific microhabitat in a specific island. This is the case in the Galapagos. There are a number of ergatoid species that have ended up there and have radiated and diversified on different islands. Some species have presumably become ergatoid, and others remain ergatoid as they arrive there. Invasive species tend to focus on dispersal. That is how they dominate the world. So, when you go to an island, you'll see mostly imported tramp or invasive species, and these ones are specialized on getting everywhere they possibly can. And this tends to cause problems for a lot of the native residents, especially if they're insects. With that detail added, let's return to our original principles. When you put all three factors together, a pattern shows up. Big islands close to the mainland, like Papua New Guinea, have lots of species, but most of them look familiar. Small islands far away, they don't have much, but what they do have is strange, unique, found nowhere else, and often, due to lack of predators, ginormous. That's the trade-off. More species or more evolution. And if you actually want to see evolution happening in real time, you don't go to the mainland, you go to an island. It's a living experiment in the middle of the ocean. I'm Josiah Kilburn, and this is Army of Insects. And as always, stay buggin'.